what I'm going to do is I'm going to talk about the distinction between simple and compound statements. I'm going to talk about logical connectives and formalization, and a little bit about dyadic formalization. All right, the first thing that I want to do here is discuss the notion of simple versus compound statements. So this is the first distinction that we run into when we're dealing with formal logic. So we haven't really gotten to the formalization yet, so that's what we'll be doing here. So we talked about what statements are. A statement is anything that can be either true or false. It has truth value, so things like commands are not statements, questions are not statements, proposals are not statements, and also gibberish are not statements, because they are things that we can utter or write down that are neither true nor false. So what would be an example of something that would be a simple statement? Well, let's talk about the notion of a statement. So when we're talking about the structure of a statement, and this is true regardless of language, but we'll take a look at English here. It's say something like, today is Wednesday. All right, so let's say that's the case. And this is a statement because I'm going to just label it S1 for the sake of having this here. So today is Wednesday. This is a simple statement, but first let's get to why it's a statement. It's got a subject. So right here, this is the subject of the sentence, the noun that it's about. It's got a verb right here. And then here, it's got a predicate. So what does that mean here? What the sentence is about? The verb, what it's doing today is. And I could stop there, but the predicate here adds back to the noun. It tells me more about the subject of the sentence. So today is Wednesday. Now, every statement will at least have that. So just something by itself. Like if I just say the word no, that is not really a statement with any kind of truth value to it or anything like that. So what that means is a statement is something where it has one truth referent. So something like this. Here's what I would do with this. And what I want you to be able to do on quiz 2 is, this is a statement. What I want you to be able to do is to represent it formally. And what I mean by that is here, we're going to basically shrink this down into something that stands for this. So what I'm going to do is I'm going to arbitrarily underline a word. There are 3 and I'm just going to pick one. Okay. I chose to do the W there. I could have done the today or the is. And what we're going to do is we're going to say, here's how we can represent the statement formally. We're going to take the first letter of the underlined word, and that's going to stand for the entire statement. So if I say today is Wednesday, the first letter of the underlined word is W here. So I'm going to write here, how do I represent this formally? So here's the statement. What's going to be the formula for it? And I'm just labeling these here. We're going to say, you can represent this by just saying W. So what does W stand for? It stands for today is Wednesday. Why? Because I said so. I could have chosen a different letter. I could have underlined today and we would have chosen T. So it doesn't, and this W doesn't stand for the word Wednesday. It stands for the statement today is Wednesday, which is a little bit different. So this is a simple statement because there's only one element here. As soon as we start bringing in other elements, it's no longer a simple statement. It ends up being compound. So compound statements are where we have bundles of simple statements. So let's look at an example of that. So we've got this still. Today is Wednesday. Now look what I'm going to add a little bit to it. Today is Wednesday, and tomorrow is Thursday. Okay, so this is an example now of a compound statement, and it's compound because it's got this thing going on right here. This is a connective. This is something joining 2 statements together. So this thing going on right here, today is Wednesday, it's its own thing. It's got its own subject, verb, predicate. Subject there, today, verb is, predicate Wednesday. But what I'm going to do is that part's going to stay the same. W is still going to stand for today is Wednesday. But then we have this, and what this is a connective. So I'm going to have W and. whatever that means, then whatever this is. Now this is tomorrow is Thursday. This is its own separate statement. I could have this by itself. So I'm just going to arbitrarily underline Thursday here. So the statement tomorrow is Thursday is going to be represented by just the letter T, because that's the first letter in the underlined word that I've selected. So this statement here can be represented by the formula W and T. Now, there's actually a formula for what this should look like. Okay, so when we get into formal logic, the symbol for and that I'm going to use is a dot like this. So what does the dot means and vice versa? So the way I could represent this whole thing as a formula is this. W dot T. So this is our fully functioning formula there. I'll call it that. So what is W dot T? What does it mean? Today's Wednesday and tomorrow is Thursday. Now I could also just have this by itself if I wanted to. What would that mean? In this context, today's Wednesday. What would this mean in this context? Just by itself? Tomorrow is Thursday. But what I wrote here, and notice there's a period on the end, so I keep formalizing until I get there. That means that's a stop. When you get to the period at the end, that means you can stop. But so this says today is Wednesday and tomorrow is Thursday with the variables that I've been given. So this means, again, a statement like just W by itself. Like if I had just this W by itself, okay, that would be a simple statement. If I had just this T by itself, that's a simple statement. As soon as we have like a symbol, not a letter like this variable here representing a statement, but a symbol that does something to fuse two or more together. And there's one exception where something is just modified. We'll talk about those. So any kind of modifier that goes where it goes from being just a simple one little statement by itself or formally one little letter by itself, anything that modifies that makes it into a compound statement. So what I'm going to do now here in a moment is we're going to get into the different ways you can connect statements together. So there are a couple of different species of that. Let's get into that. So the first one I'm going to talk about, actually we were just talking about it a moment ago, and that is the notion of a conjunction. And so conjunctions are and statements. So there's other words that mean and as well. But yet, moreover, nevertheless, and I'll talk about that more when we get to conjunctions. The symbol I'm going to be using to represent and statements conjunctions is going to be a big dot like this. Now some people use an ampersand to represent and. I'm not going to even attempt to draw that. But you will see it out there if you Google conjunctions. And also some people use, it looks like an upside down V or like a mountain on a map. Just so you know that it's out there. It's out there. But I'm going to be using the dot like this. That's going to be my symbol for and. So as an example of what a compound statement would look like with that, if you see this, A dot B, whatever A is, let's say today's Wednesday and tomorrow's Thursday, like we were doing a little while ago. That A stands for today is Wednesday, B stands for tomorrow's Thursday. This is today's Wednesday and tomorrow's Thursday. You can say A dot B, you can say and A and B. Either one of those are fine. Okay. Another kind of connective is the conditional. Conditional statements. Sometimes they're called implications. These are what we'll call if-then statements. And there's other ways to represent if-then as well. Just like and had synonyms like but and yet. There's synonyms for if-then. Some of them are kind of peculiar. Like only if. I'll cross that bridge when we get there. But if-then statements are going to be represented with an arrow always pointing to the right. I've seen some people have arrows that point to the left, right? That means something else. And so I don't want to deal with it here. Sometimes people use instead, if you look this stuff up online, you'll see this thing called the horseshoe. Looks like a U on its side. And I can never remember, is this side the part that's doing the pointing like a bullet? Or is it this side like a magnet that's doing the pointing? I can never remember which is which. So I don't even bother with it. I just use the arrow. So sometimes when I'm referring to conditional statements, I'll refer to them as arrows. And what that would look like is something like this. If you saw A, arrow B, that means if A, then B. So if we had the variables that we had earlier, A stands for today's Wednesday, B stands for tomorrow's Thursday. If today's Wednesday, then tomorrow's Thursday. I filled it in there. Biconditional. Now, in everyday talk, we don't use this very often, unless you're a logician. This is if and only if. So a biconditional statement is a statement where something works in both directions. So I think an easy one would be if I have a shape that has three sides, then it's a triangle. Well, guess what? Also, if I have a shape that's a triangle, then it has three sides. That works in both directions. The arrow really is literally pointing in both directions. When that situation happens, it means you have a biconditional statement. So really, I could just take this out and put, listen, three sides if and only if it's a triangle, or it's a triangle if and only if it has three sides. So that's how that works. And so we use this a lot in mathematics and legal language, but it's not something that we use every day. So since that arrow works in both directions, the symbol I'm going to use for it is a double arrow, an arrow pointing in both directions. There are some people who use this thing that looks like a mega equals sign. It's got three bars like this. I'm not going to use that, but I want you to know that it's out there in case you encounter it if you Google this stuff. Okay? And an example would be A, double arrow. B is the way I say that, or A if and only if B. I said this out loud with the variables that we had earlier. Today is Wednesday if and only if tomorrow is Thursday. Based on our calendar now, that does work. Disjunctions. Now this one gets a little bit more complicated. And that is, these are or statements. Okay, now, what's the symbol for an or statement? There's two, because there's two different kinds of disjunctions. There are the inclusive kind, and there are the exclusive kind, and they get different symbols too. And when we get to it, I'm going to make it as clear as possible what the distinction is when we get there in the semester. But I'll say this, inclusive, the symbol for it is called the wedge. It just looks like the letter V. I try and make it a little bulky to distinguish it from the letter V. And for exclusive, I use the sniper sight. So, circle with a little cross on the inside. And these mean different things. So an inclusive disjunction is where you're saying something is one thing or the other. Can be both. So that way that would look something like this. So here it is in practice. So let's use some different variables here. Let's say A stands for you can get the soup. B stands for you can get the salad. So you're in line, you can get the soup or the salad. It's not impossible for you to get both. So what this means is you can get one or the other, or you can do both. You don't have to, but you can. It's possible. Now, exclusive disjunction, on the other hand, that's where you've got a choice between two things, and the choice is absolute between the two. They both can't coexist at the same time. You've got to pick one or the other. So an example of that, maybe you're at a restaurant where, no, they're really strict. You're going to get the soup or the salad. There's no way you're going to have both. It's still conceivable. That is, it's possible. So I'm going to say that would not be an exclusive disjunction. And an example of that would be something like, let's say we had a Tuesday-Thursday class. Okay, and you fall asleep in class. You don't know what day it is. Well, you know it's Tuesday or Thursday. And there's no way that it can be both. Like, yeah, there's, that thing happens, like, at New Year's where, Eastern Time's an hour and ahead. Eastern Time, people in Eastern Time were in 2021 an hour before people in Central Time were. Okay, oh, so it's both, Monday and Tuesday at the same time. Cool. There's no way that it can be Tuesday and Thursday at the same time. So if you wake up on a Tuesday-Thursday class and you don't know what day it is, it's got to be one or the other, but there's no way they can be both. That's an example of an exclusive disjunction. So nicknames for these are just or statements. And sometimes I'll just call them or statements. That one's pretty straightforward. The exclusive, sometimes they're called XOR statements. XOR. Okay. Exclusive disjunctions. Then let's come to the last of these connectives. negations. Now, negations are strange connectives because they're connectives. These all connect. The negations actually don't, even though we could call them a logical connective. It might be better to think of connectives as modifiers. These all modify A and B, or whatever letter I have in play. They all take two things and they put them together in various ways. These are junctures. Negation is not really a juncture, but it is a modifier. So what do I mean by negations? Anything that means this. Not, in English, there are a plethora of ways to demonstrate a negation. Typically by prefixes on a word, but also by contractions as well. Now the symbol that I'm going to use in here for negation is going to be the tilde. Looks like a squiggle. Some people even call it the squiggle. And it's the same kind of symbol you see over the N in a word like jalapeno. So what does that look like? Well, you're never going to see A squiggle B. That's not a thing ever. You can only stick these things in between any two simple elements. So here's the way negation works. Let's go back to what I was using originally. Let's say A stands for today's Wednesday. Well, squiggle A would just be today is not Wednesday. So it's Thursday. No, it could be Friday, or Saturday, or Sunday, or Monday, or Tuesday. Like, the list goes on. It could be any of those other things. So all this means is not that thing. But it's still a modifier, and this is something independent on its own. This is still, it looks simple because it's one letter, but it's not. It's compound because it's more than merely A by itself. It's squiggle A, not A, the negation of A. So what you see here are all the connectives that you're going to encounter. These are the most basic logical connectives. And really, we're going to spend the first chunk of the semester looking at, first of all, conditionals, then conjunctions. Then we're going to look at negations, then biconditionals, then disjunctions. And that right there is 2/3 of the semester. We'll be going through these different connectives, learning the different things that you can do with them, and how that's helpful. Now, there are other connectives that exist out there too. And they're in the last page of your syllabus as well. So things like backwards E's, and upside down A's, squares, and diamonds. And these are things in predicate logic and modal logic. And again, you can refer to the last page in your syllabus to see what these mean, but they are not part of the content for this class, because here we're doing basic propositional logic. Okay, so other connectives exist out there, but these are the most basic ones, and so these are the ones that we're going to learn about in this class. So the next thing that we're going to have to learn about these is going to be the notion of them being well-formed dyadic formulae. So here's the next thing to know about formal logic is all compound statements need to be dyadic. Now again, the negation is kind of a slight exception to this, at least so what I mean by that is this is technically simple. This is technically compound, even though there's only one variable or letter involved here. But for all the others, for the arrow, for the dot, for the wedge, for the sniper sight, for all of these, okay, the if then, and also a double arrow as well. Let me stick it up there. For all these, you can have if A then B. This would be A and B. This would be A or B. This would be A X or B. This is A if and only if B. Okay, and I'll put those up there again. So this isn't what that arrow means is if then. What that dot means is and. What that wedge there means is or, and what that sniper sight means is like what I call X or. It's an exclusive or. Like pick one or the other, and then this one here, sometimes this is abbreviated in math, if and only if. If. The deal is with these are all what are called dyadic. So all formal statements of logic require them to be dyadic. Now here that's pretty easy. All that means by dyadic, by the way, dyadic is just a dyad is just a fancy word for two. So when you're saying dyadic, literally it means two-ish. That's all that it means. So here we have these dyads. So here, for example, the A. That's the left side. Left side, we got the right side. Boom. Two sides, it's a dyad. Okay, so all these are dyadic. That means they require a left side and a right. And we'll see we've got that here for both. We have a left side and right side. Here, this one's got a left side and right side, left side and right side, left side and right side, left side and right side. So these are all dyadic. They're good. And what do I mean by, how could it be otherwise? Well, look, if I put A arrow, and then there's nothing over here but emptiness, this is not dyadic. Okay, this is wrong. So you can't say if A, then, and then nothing. Okay, so like if today's Wednesday, that's not a statement that you can use. And in fact, being dyadic is part of what we call being a well-formed formula. All right, or for short, WFF. So just like in math, in logic 2, we got to put things the right way. So basically, you can't have like neither can you have like an arrow over here just floating and maybe put a letter on top of it or something. No, you got to put it together correctly. And so what I mean by correctly there is if it's any one of these arrows, dots, wedges, sniper sights, or double arrows, it's got to have something on the left side and the right side. It's got to have both. It's got to have a left and a right. That's what I mean by dyadic, and this makes it a well-formed formula. There's other aspects of it's just a well-formed formula. All that means, you probably heard it in other kinds of math before, but all that means is just putting something in the most efficient way possible. So, like, what I mean by that is, let's say, hey, write the number 5 up here. And I went, okay, 5 is 1 plus 1 plus 1 plus 1 plus 1 over 1. Is this 5? Yes, it is. Should you write it that way? No, don't do that. You're being obtuse. So if I say, hey, write 5, here you go. If you're going to get really spicy, I guess you could write a Roman numeral. So all three of these things here, these all are equal to each other. This means 5, this means 5, this means 5. But when we say like we want a well-formed formula, like there's a certain sense in which this is correct, but you're putting too much work into it. Okay? It's not as simple as it could be. So all that it means for something to be well-formed is it to be simple in this sense of it, you don't put it in an overly complex way, 1. And 2, that it's packaged the right way. The formula has the right kind of structure, like being dyadic. That's all that means.